Hello, welcome to this video where we will be discussing RSS and LQI, which are both signal and packet quality indicators. And those have important implications when it comes to your KNX IoT installation and when it comes to troubleshooting connectivity issues. So here we have our Cascoda sniffer, which we will be using to sniff the traffic and extract those quality indicators. And here we have our two KNX IoT devices which are already operational. So if I press a button on one of them, it toggles the LED on the other, and vice versa. So the first step is to connect our Cascoda sniffer. So let's do that. Now to follow along, please make sure you've got access to the Cascoda Windows tools, which you can install in our SDK under releases, which is publicly available. So if you install Cascoda Windows tools, you'll have everything you need to follow along. So the first tool we'll be using is Chili Control List, which allows you to make sure that you've got your sniffer connected. So it's a Chili 2 device with the Mac dongle application, and here we have its serial number. Next, we'll start the sniffer. So sniffer-S for the serial number. -W for Wireshark. And then here you have to provide your channel number. In my case, it is 23. In your case, it could be some other number. So let's press enter. Alright, so now we've got Wireshark in capture mode, capturing all of our IEEE 802.15.4 packets. So let's see, if I press a button here on one of the devices, you can see that we have a few packets that have been generated. Now, in another video we made, we already go over what those packets mean and how to decode them, etc. In this tutorial, I will be focusing on the link and signal quality metrics. So for that purpose, let's just select any of the packets, for example this one, go over to the bottom left pane, and then here there is a section called IEEE 802.15.4 tap. Let's expand this section, and you will see that there is RSS, -28 dBm, and then we've got link quality indicator 255. Now I will explain exactly what those mean in a second, but in the meantime, let's make it more convenient for us to view those values for every single packet. So if you expand RSS, click on the number here, and then right click, apply as column, you can see now we have a convenient column where we can view the RSS value for every single packet. So let's do the same thing for the link quality indicator. Oop, I made a mistake here. I should expand this. Click on this one, right click, apply as column. Let's go ahead and delete this one. All right. So now we've got our RSS values and link quality indicator values for every single packet. So I will explain now what those numbers mean because they can be a bit confusing. So RSS stands for received signal strength. It is the actual power of the signal as measured on the receiving device, so in this case our Cascoda sniffer, and it is a measure of signal quality. It is measured in dBm or decibel milliwatts. So it's a power ratio based on 1 milliwatt, and I will make this more concrete in a minute. But for the link quality indicator, that's an indication of the quality of the data packets. And so this is judged by the number of errors in the modulated signal as received by the sniffer in this case. So to summarize, RSS is to do with signal quality, and the link quality indicator is to do with the quality of the data packets. So let's have a look at some actual numbers here. So if we go to a decibel milliwatt to milliwatt converter, so a value of 0 dBm corresponds to 1 milliwatt. Now any negative value will correspond to a number smaller than 1 milliwatt. So for instance, if we go to negative 30 dBm, that's simply a decimal point shifted 3 times to the left, so that's 0.001 milliwatts. And if we pick a number greater than 0, then we'll have a number larger than 1 milliwatt. So don't let the negative numbers confuse you here. They simply mean that the power of the signal is smaller than 1 milliwatt. Okay, now one important thing to note about decibel milliwatt is it is a logarithmic scale. And what that means is two numbers that are close together in the decibel milliwatt scale will actually be quite different when you look at the milliwatt value. So I will show this with an example. Let's say you've got a signal that has an RSS of negative 30 dBm. So that will correspond to 0.001 milliwatts. Now, if you decrease that value only by 3 points, you will notice that the signal power is actually divided in 2. So if you have an improvement of 3 dBm, that means that your signal is twice as strong. So let's go back to our Wireshark here and look at some values. So negative 28, negative 28, negative 32, negative 31, negative 73. Now typically with an RSS of a negative 100 dBm, you can hold a conversation over cellular. And also typically any number above negative 70 dBm, so for example negative 60 dBm, negative 40, negative 30, those are all considered to be quite good signals. So here you can see most of our signals are quite good, except this one, negative 73. And as you can see, the link quality indicator shows that this affects the quality of the data packet. So here we have values of 255, which is the maximum value you can have for the link quality indicator. And it is the best value. And you can see that as the RSS goes lower, so the signal is weaker, then you have a lower, worse link quality. So what's the implication of all of this? Well, if you have a KNX IoT installation, and for some reason, some of the devices don't seem to be communicating reliably with each other, then you can use the Cascoda sniffer in order to sniff the packets being sent from a specific location, and you can determine the signal strength received by those devices at a specific location. And if you notice, for example, that the received signal is really weak, for example, with an RSS below negative 70 dBm, then you know that you've got a problem when it comes to the location of your devices. So let's look at the effect of this in real life. So if I scroll back to the bottom, I will once again press the button here. You'll notice RSS of negative 29. Now if I do the same thing but cover the device with my hand, which will attenuate the signal, you'll notice that we have a worse RSS value, so a lower RSS value, which shows that the signal was attenuated. Same thing if I move the device further away. So once again, I will press the button here. We've got negative 29.5. If I move it all the way to the end and press the button again, Here we have a value of negative 33.5. So that's it for this video. I hope you have now a better understanding of what LQI is, what RSS is, and the implication of those values when it comes to your KNX IoT installation. Thank you for watching.